Hi, so in this video I'll be showing you how to draw as well as explain the graphical methods of finding the shear force or producing a shear force diagram as well as a bending moment diagram, and we'll also be utilizing the polar polygon as well as creating a funicular or link polygon in the process. Alright, now I'm just going to get into things by first sketching my beam. And my beam, I'm going to use my rectangle command. And I'm just going to draw a little rectangle with the width be 5 and 5 is 10, and 7 is 17, and 2 is 20. So 20 tab, and the height is going to be 5. Alright, so this is my beam here. Let me make it a bit smaller. Let me turn all this here. Alright, now on this, now I'm going to add my forces, and I'm going to use a triangle to depict that. Alright, three-sided polygon. One is going to be here, and this one is going to represent, or this here represents my what do you call this, like a wall or a column underneath the slab. Alright, so one is going to be there, and then there's going to be one on the next side here. Alright, now that we have that in place, I'm now going to indicate the down forces or the down point forces, and they are basically these here. So this 5 here, this 12 here, and this 10 here. So that's what I'm going to be using. Now I'm going to simply use my triangle here to point out where they are, and I'm just mirroring that to that side there. Alright, but I don't know exactly where they are, so I'm going to use some measurement based on what I have over here. So the first one, so what I'm going to do is that I'm going to draw this line all the way down. This line here, let me move it over by 3, as indicated by the 3 meters here. Then I'm going to copy it over to my right by 5. Alright, then I'm going to copy over by 7. Alright, and then I'm going to copy over by 5. Alright, let me grab this here and make a copy as well on the next side, and you'll see that this comes into play later on. Alright, so here's what I'm going to do. This force here, let me move it and place here, and let me make some copies. Let me put a little tick there. So this force here, one there and one there. Alright, representing the forces. Let me add some text. Alright, so text using multi-line. Alright, text, so I'm going to make this 5. Now that's a bit big. Let me make this about half the current size, 0.5. That should be good enough. Alright, and let me copy to the other locations, and then I'll edit the number or the value. Alright, so I'm going to say that this is the 5 kn. This one here is 12 k kN, and this one here is 10 kN. All of these are still a bit large, but I'm going to leave them for now. I'm going to add my Bose notation. So this first one is going to be A, and I'm going to copy it to the other location. So right there, there, and there, and this is B. We have C, and we have D. Alright, so once you have those pointers labeled, I can also dimension these just to give you an indication of what is going on here. So between here and here, that's 3 there. Now my dimension size is a bit large, so what I'm going to do, let me edit my dimension style, dimsty, modify, our text, let's make that 1, symbol, let's make that 1, alright, okay, set current, and that should update. Alright, still a bit large. Let me reactivate and change my symbol size again to something even lower. I'm going to make it 0.5. Alright, okay, set current, close. Alright, that's better. Now let me add some more dimensions. So for example, here and here. And I'm just going to use the continue dimension from here. Alright. Now I'm also going to label where this wall here underneath the slab or the beam, this one here, and I'm going to call them RL over here and R right over here. So let's add a text, CP, space it here, RL, RL, L, and this L here should be lower, like this. Alright, let's make this text a bit smaller. Let's scale it to about half the current size, 0.5, and let's paste a copy at the other location. This is R. Alright, just like that. Now that that is in place, the next thing I'm going to do now, we can now create our bending moment diagram by using a funicular link polygon. Alright, so let me grab these here and start out my layering. So these are on my construction layer. These here are on my dimension, or I should have an annotation layer, dimension, and these annotation layer if I do. Alright, so this goes to here and there and there and there. Alright, let's paste this on annotation, match some properties. So this goes to here. These are going to be object. Alright, and I'm matching the property of this dimension to this, this, and this. Alright, for my forces, let me see what I'm going to place these on my match there, at least for now. Alright, now that that's in place, I can now create my shear force and bending moment diagram, but we're going to start by first creating our polar polygon. Alright, and when we're creating our polar polygon, we need to create our load line. Alright, so I'm going to start things off by first drawing an horizontal line across here, just like this. Alright, and I'm going to place these on, let me put it on my center. Alright, now what I'm going to do now is that I'm going to be creating my load line running along here, as you can see here. Now this load line represents each one of the force is acting down on this beam here. Alright, now for you, you will select a suitable scale. So you could say, alright, you see, for every 1 kilonewton, I'm going to make my line 1 meter or 1 millimeter, whatever it is. Or you could say that for every 1 kilonewton, I'm going to make my line on my load line 2 meters. Alright, now for example, the first one here is 5. If you are going to use a scale of 1 to 2, you know the line is going to be 10 long. Since I'm going to make mine 1 to 1, my scale, I'm going to make for every 1 kilonewton that I'm going to use here, I'm going to make my vertical load line 1 meters. Alright, so what I'm going to do, this is 5 with the current scale that I'm choosing. I'm going to make this line 5 as well. Alright, and this would be the first one. Let me just quickly add a little point here, just alright, PT for point type. Let me change this to something like this. Okay, alright, let me edit it a bit more, make this 2 absolute, .5. Alright, so this first line here represent this 5 kilonewton force, and it is located between Bow's notation A and B. So what I'll do, I'll simply write, let me copy this here. So this point here is A, and it's going to be in common letters for me. Let me change the font size to 0.5. Alright, so that's A right there. Now, where the line ends, I'm going to call that point B, because this force here is located between point A and Bow's notation B. So I mark this, and I'm going to call it point B. Alright, now I'm going to repeat the process. So for example, this 12 kilonewton here, with the scale that I'm using, I'm just going to draw the line 12. Alright, and this force here is located between point B and C. So what I'm going to do, I'm going to copy this here, and I'm going to place it down here, and I'm going to call it point C. And notice that it is in common letter. Alright, now the final force, which is this 10 kilonewton here. Alright, I'm going to draw my line here 10 as well, so I'm going down 10, because based on the scale that I'm using, so I'm going down 10. Alright, and this line here represents the 10 kilonewton force here, and it is located between point C and D. So I'm going to mark this point here and call it point D. Common letter D. Alright, now once I have my load line in place, I'm now going to identify my pole. Alright, and if you're wondering what the pole is this here. If you're wondering the location, this point here is random. But because I want mine to look neat, I'm going to put it somewhere in the middle of these forces here. So I could possibly say that, okay, I want to place it right here. Alright, right there. And that is going to be my pole. Alright, now once I've identified my pole, alright, I'm now going to draw lines diagonal lines from each point. So I'm going to draw a line from A to the pole, then to B, alright, then from C to the pole, then to D, just like that. Alright, now again, this over here represents my polar diagram. So if I were to label all of this here, polar diagram, alright, so this is my polar diagram, and you can also call it your polar polygon as well, because it is a polygon. Polygon. Alright. Alright, now once that is out of the way, you can also add your, make your notation, because this is your load line. So let me copy this here just to label my drawing. Load line, and let me stretch this out a bit and then rotate. Alright, so this is my load line. Now let me move this out over a bit. Alright, so our polar diagram, polar polygon is right here. Now from this we're going to generate our funicular link polygon. Alright, so what we're going to do, you see these lines here, I'm just going to extend them down a bit further down here. Alright, and I'm extending them. Alright, everything here, extending them down. Alright, get rid of this. Now what we're going to do now is that we're going to create our link polygon. And how are we going to do this? And this is also going to represent our bending moments diagram as well. So what we're going to do, we're going to start by copying this line here, which is line A to the pole. Alright, so we're going to copy it, and the reason why I'm copying it is because I want to have a line that is parallel to this one here. Alright, I'm just going to place it somewhere down here. Alright, just like that. Now once I've done so, the next thing I'm going to do, I'm now going to work my way down. So I'm now going to turn my attention to point B here, and I'm going to copy that, and I'm going to place it wherever this force here end, basically right here. Alright, just like that. Alright, now if I turn my attention now to C, alright, and I copy C, if I copy C and I place it where? Right here where the line ends. Alright, and if I repeat the process for this one here, right here, this one here, me copy, alright, right here. Alright, now what is going on here is that I have created lines that are parallel to each other. So basically all I did was to simply copy those lines because I wanted them to be parallel. And when you're copying things in AutoCAD, you automatically make the line that you copy, or the new line that was created, parallel to each other. Alright, now once you have done so, I'm going to encourage you to draw a line across the top like this, and in doing so you're actually creating your link polygon. So inside here you can say, refer to it as your link polygon. Alright, your link polygon. So this is your link polygon. Alright. Now once you have done so, I'm also going to say that you're going to now utilize your fillet tool, and this is what I recommend. And you're going to fillet this last line here, or this first line here, which is representing your first line here, which is your 5 kilonewton, and you're going to extend it or fillet it to meet the last one here, which is representing your 10 kilonewton line there. Alright, now once you have done so, you see this line here, or this figure here. This figure here represents your bending moment diagram. Believe it or not, your bending moment diagram. So this is representing your bending moment diagram. Right. Oops. So this is representing your bending moment diagram right here. Alright, now you see wherever this baseline here, or these lines that were filleted meet, you're going to draw a vertical line up from that point to meet. Well, you don't necessarily have to meet, but you send that all the way up to, and I'm going to send it to my beam here. Alright, now this line here represents your equilibrant. Alright, so you want to think about this point here as where everything tends to balance out in terms of your weight. Because you can think about this here, you have 5 year, 15 year, and 10 year. It's as if it's heavying out as it's going to my right. Alright, but there's going to be a point in this here. Think about it like central, where the center of all forces are acting. Alright, where everything kind of balance out, if you want to call it that. Everything balance out at this point here on the beam. Alright, it's the reason why they call it an equilibrant. Alright, and I'm going to go ahead and label that as well. Equilibrant. So this line represents your equilibrant. Alright, equilibrant. Let me make this text a bit smaller, 0.5. So this is your equilibrant. Let me make this text a bit larger. Alright, make it 0.8. Alright, so your equilibrant somewhere there. Alright, now once you have done so, the only thing that's left for you to now do is to create your shear force diagram. Alright, and if you're wondering what the shear force diagram is, this right here is your shear force diagram. Alright, but before we do so, what I'm going to encourage you to do is that you see this line here, and let me change the color of it. You are going to copy this line here. Alright, and you're going to place it at your pole like this. Now you see wherever it touches your load line, and I'm going to choose the trim command to get rid of the excess. This line here also represents a equilibrant force line as well, you know. Alright, so you can think about it like that as well. Now once you have done so, here's what you're going to do. You see, from all these points here, simply project a line across your graph here, in a sense, because in a sense what we're doing here is we're plotting a graph, you know, of the forces acting on the beam. Alright, and it will take us up and down and wherever depending on the loads. So what I'm going to do, let me grab this line here and I'm going to place it at each one of those load points like that. Alright, now once we've done so, the next thing we're going to do is now we're going to plot the shear force diagram. Alright, and I'm going to write, let me just write shear force diagram just below. CP shear force diagram, this is it. Shear, shear force diagram. Alright, so this is my shear force diagram that I'm going to be drawing. Basically this figure here. Alright. Now what I'm going to do, I'm going to start things off, and let me switch my object layer here. Alright. Now what I'm going to do is that, you see, wherever this equilibrant line here is, I'm just going to run my cursor over it until it gets to this end here. And what I'm going to do, I'm going to draw a line up from this point here, all the way up to the top where point A is. Now what I'm going to do, I'm going to be drawing horizontal lines, and you're going to do this horizontal line to each one of the forces. Alright, so here's what happens. Here is all nice and dandy, everything is running smoothly. Alright, and it's all nice and smooth until it gets to the 3-meter marker, which is right here where this 5 kilonewton force is happening. And you can imagine this as you walking with your hands out, and then somebody threw a bag of cement in your hand. What is going to happen? You probably fell, or you probably stumble a bit. Alright, your hand is going to sink. So this is what is happening here. 5 kilonewton force drop on it, you simply dip. Alright, and it dips to the next force level. Alright, the next force level, which is B right here. Now think about what is going on here. So at this B section here, nothing's going on. So what are we doing? Once nothing is going on, we're moving constantly on a level, flat, horizontal plane, running across like this. Alright, until we get to the 12 kilonewton. Alright, 12 kilonewton is heavier than the 5, so we add it more. So where is it going to dip? It's going to dip right down to this equilibrant line here. Alright, now once you get to that point, nothing is going to happen. Alright, so what is going to happen is that we're going to stretch our line all the way over to the top like this, or to the next side like this. Alright, the end of the beam. Alright, just like that. Then now we're going down to the bottom of the force line here, or the load line, and it's as if we're doing the opposite of what we did up here. So this way we are going down, and on this side here we're going to be going up. So think about it like this. Everything is all nice and smooth here until we get to this 10 kilonewton marker here. So we go across. When we hit the 10, bam. Alright, then everything is all nice here again. So we're just going straight. We're going straight. And then bam, right there. Alright, so everything is straight there. Now when the 12 catch it, what is going to happen? Straight up in the air. Alright, and then we simply close off the base right there. And notice what happened here with this force here. Everything tends to balance out at this point here. So basically this is how the load acts on RL and R in a sense. So remember, this is like you have one column here, or one wall here, one wall here. Heck, you could think about this even like a car, where this is the car itself, and you have the front wheels here, or the front wheel here, and the back wheel here. Alright, so you can see the shape that has been formed. This is representing your shear force diagram, and as it says shear, so everything is pretty much sharp. So everything happens sudden. Everything is just happening at a sharp pace. So it goes smooth, a shear force, sharp, so it drops. Everything is all Gucci here, drop. Everything is all Gucci and nice, and it continues over and over. You know, you label these points, you can dimension them. So think about it like this. This side here represent RL, alright, which is over here. So basically from this point to this point is from A here to here. Alright, and from this point here to this point to this point represents from here to here. Alright, so if you want to look at it another way, so from here to here, 13, and here to here. Alright, so in a sense, what is going on here? Down this side represent RR, up on this side here represents RL, or the left side. Alright, so and here and I always call this outside your equilibrium force, and I'm just going to call it, and you could call it the same thing as well. I'm going to call it my E force line. So my E force line, CP. So my E force. So this is my E force. So this line represents my E force line. That's the blue line right there. Alright. Now this is my simple version, well, my explanation of producing a funicular link polygon to get a bending moments diagram as well as a shear force diagram. And this is done using the graphical method. Alright. Now this is just a simple thing. I stretched out the video because I wanted to keep it slow and explain things as best as I could in terms of like describing this process here. Alright, as you can see, you can label the different points. So everything is labeled in relation to these points here. Going down, so you could tag these points using Bose notation and what it represents, so on and so forth. Alright. So here we go. I hope this video was educational. I hope you learned something. And if you do, or if you did learn something, please like, subscribe, and share with others. Alright? Alright, thanks for watching.